Hey, so this lesson is on solving exponential equations. We're going to be applying everything that we've been learning for this unit into solving actual equations. I know that we've been solving for x and you've seen it in lessons, but this is a little bit more complicated. Some of it is the same though. So the best way to learn these is by doing examples. So first of all, this is a property that you already know, but basically one way to solve exponential equations is to use the property that if two powers with the same base are equal, then their exponents must be equal. So we know that for when b is greater than 0 and b doesn't equal 1, if b to the x equals b to the y, then we know, and hopefully you're saying it to yourself already, x equals y. So this is going to be a really important property for us to use throughout solving these. Same thing with the logarithms, but we'll talk about that in a separate lesson. So looking at our first example, we have 4 to the 3x equals 8 to the x plus 1. I've been emphasizing for the last week or so that our main goal is always to get the same base if we can. We can do a lot more when we're working with the same bases. Well, even though we know 4 times 2 is 8, we can't actually get them to both have bases of 4. However, we can get a base of 2. So here we're going to have 2 squared, and that's going to be to the 3x power, equals 8 is 2 to the third to the x plus 1 power. Well, we know 2 to the second, we're going to multiply the exponents, we're going to have 2 to the 6x equals. Now remember, this is x plus 1, so we have to distribute our 3 to both terms. So please, this is where you're going to make careless mistakes. So it's going to be 2 to the 3x plus 3. Well, going back to that property we just talked about, we know that once they have the same base, we can set the exponents equal to each other. All right? To solve for x, we want all the x's on one side, so I'm going to subtract 3x. I'm going to get 3x equals 3. Obviously, divide by 3. And x is going to equal 1. Well, what have you learned when doing these equations? You have to, hopefully you're thinking to yourself, check for extraneous solutions. Check your solution, which we'll talk about the extraneous part in a second. But it's always good to check. So 4 to the 3 times 1 is 3 equals 8 to the 1 plus 1. Well, 4 to the third is 64 equals 8 squared. So 64 equals 64. And we're good to go. We know that this is our solution. X equals 1. Now sometimes it's not convenient to write each side of an exponential equation using the same base. Looking at this example, 2 to the x equals 7, there's really no way for me to get a base of 2. So we're going to use logarithms to, on each side to solve this. So 2 to the x equals 7. Do you agree or disagree that if I take the logarithm of the same base of each side, I really am doing the same thing to both sides and therefore not changing the value of it? It's like saying x equals 7. Well, if I multiply both sides by 3 and get 3x equals 21, I still have the same value of x equals 7. Well, we're going to do that here. We want to get rid of this this base of 2 here so that we can solve for x. So to do that, I'm going to take log base 2 on both sides. So log base 2 of 2 to the x equals log base 2 of 7. Because this log base 2 is the same on both sides, I'm really not changing the value of this original equation. But it does allow me to work with it more because log base 2 of 2 to the x is the same thing as x times log base 2 of 2. Of course, we can't do anything with log base 2 of 7. But this gives you x times 1 equals log base 2 of 7. So we know x, which is what we're trying to solve for, is log base 2 of 7. Well, how do I find that? By using the change of base formula and a calculator. So log base 2 of 7 is the same thing as log 7 divided by log 2. And if you plug that into your calculator, you are going to get an approximate value of 2.807. I would check this in the original equation by putting, 2 to the 2.807. Now remember, this was an approximation, but it should more or less give you 7. If you put that in your calculator, it does. Now things are going to get a little bit more complicated. Here I have 10 to the 2x minus 3 plus 4 equals 21. We still want to get the exponential section by itself so that we can solve for x. So the first thing we have to do is subtract 4 to get rid of the 4 on the left side. 10 to the 2x minus 3 equals 21 minus 4 is 17. Now to get rid of the exponent, or not to get rid of it, but to separate the exponent, I'm going to take the log of both sides. Now I have a base of 10 here, so I'm going to take the log base 10, which is just log. So log of 10 to the 2x minus 3 equals log of 17, because what I do on one side I have to do on the other. This leaves us with 2x minus 3 equals log of 17. Now, we want to get x by itself, so you're going to do what you normally do. I'm going to add 3. I'm left with 2x equals 3 plus log 17. And then I'm going to divide by 2. Now this is going to leave me with x equals, either you can look at it as 3 halves plus log 17 halves, or we can do 1/2. Actually, I should write this. Sorry. Write this on the other side where I have more space. This is going to be x equals 1/2 3 plus log 17. This might be easier to put into your calculator, but you can do it either way. But once you get it, you'll get about 2.115 if you use your calculator. So I want you to check your solution by plugging it in to the original equation. Do that now. Okay, hopefully you saw that you got approximately 21. Might not be exact because you've rounded it, but it should be close enough to prove that this is a solution. Looking at one more example, I want you to pause the video and try this on your own. All right, the first thing you should have done was add 16. And that leaves us with 0.2 times 10 to the x power equals, 30, 40, 51. After that, you should have divided by 0.2 and gotten 10 to the x equals 255. Well, now we have that x by itself. We want to get rid of it. So we're going to put log base 10 of 10 to the x equals log base 10 of 255. Log base 10 of 10 on this side cancels out, and we're left with x equals log of 255. Well, you can plug that into your calculator, and hopefully you got approximately 2.407. Now remember, if this is a question that you weren't using the calculator for, this would have been the acceptable answer in the end. But right now we are using calculators. I just want you to be mindful that I only want you to use calculators for the very end. I want you to get into the habit of doing these problems on your own. So we'll work on these in class tomorrow, and then we'll watch another video about solving these same equations but with logarithms. Thank you.